All right, hello there, geometry class. We're on section 2.2, areas of trapezoids, rhombuses, and kites. So we've got the trapezoid right here, and hopefully you remember what a trapezoid is. So hang on one moment, please. I have some interruptions going on. Hang on. Okay, so we've got trapezoids, and hopefully you remember that a trapezoid has parallel sides. So we've got the two arrows here. That's implying that we got parallel sides. And again, you should probably know that this is the formula here. So we've got the 1/2 height. And then notice we got to add the two bases together, and those are in parentheses. So the bases are always, always, always the parallel sides. Sorry, lunch is getting out. You probably hear the kids in the background. So the bases are always the parallel sides. So we'll add that there. So when you're looking for them, sometimes these might be turned. So that's fine. Just find the two sides that are parallel. And the height, again, isn't necessarily a side. It's perpendicular to the bases. So we've got this right here. That's our height. Sorry about that. My office is here, and different people need different things. So sometimes it gets loud. So that's what that was happening there. But let's go ahead and look at the rhombus and kite. Sorry, I'm kind of distracted after that. The rhombus and the kite, okay, is right here, which is so cool because I bet you've never known there's an area formula for a rhombus and a kite. I bet you never, ever, ever, ever knew that. And all you have to do is take half of the diagonals multiplied together. 1/2 of the diagonals multiplied together. And remember, how do you tell what a rhombus is? 4 equal sides. Diagonals are also perpendicular. And how do you tell a rhombus? 2 sets of consecutive sides the same, and diagonals are also perpendicular. So let's try a few problems here. Add these to your formula sheets if you need to. And no, a trapezoid can also look like that, guys. Okay, this looks more like an isosceles trapezoid, but this is also a trapezoid, and in this case, you might have B1 and B2, and the height would be a side whenever it's perpendicular like that. All right, so what's the area of this trapezoid? So again, always write your formula. Formula, formula, formula. Next, locate your items. So if you think you know, go ahead and put in the numbers. I'll just give you a second here. Hopefully you located the two that are parallel right here. So those are your bases. So 12 and 15 are the bases. And then hopefully you notice that the height is right here because of the perpendicular. So let's do this. 12 plus 15, order of operations, 27. Half of 7 is 3.5 times 27. That is 94.5. There's no unit here, so when there's no unit given, just put UN for units, and it is squared because of its area, because it is an area. All right. One moment, please. Okay, so I'm looking at the next one right here, and I'm going to start with the 1/2 height times B1 plus B2. It's a trapezoid. Always making sure you look at something. What kind of figure is it? Get the right formula. That's half the battle. We can tell the two parallel sides are here, so that's the 5 and the 7. Height is right here. Don't know the height. But but we could put the height in right here. And then we know this from here to here is 5. So from here to here is 5. That leaves this to be 2. And I'm wanting to use a 30, 60, 90 triangle, but I am sitting here thinking, why do I feel like you haven't learned that yet? So I'm going to pause the video here and see if we did that yet. I can't remember. Hang on. Okay, good. So you did do it. There's a whole chunk I haven't gotten to yet in the class, so that's in between now and then. So we're good. So yes, you will have had the 30, 60, 90 triangle already. And if this is 60, that makes that 30, and there's your right angle. Remember, across from the 30 is your x. Hypotenuse is 2x, and across from the 60 is x root 3. Whoopsie. That's the 45, 45. All right. So we have x is right here. 2. So what's my height then? 2 root 3. Perfect. So let's go ahead and put the 2 root 3 in here. Oh, that kind of works out nice because, well, this is 12. You always want to do those parentheses first. But the half of the 2, those cancel each other right out. And so I'm left with 12 times square root of 3 and meters squared. So that's where these get a little complicated. So it's no longer just, oh, take my numbers, punch it in, get an answer. You have to use some of these other techniques that we've had before, maybe sine, cosine, tangent, 30, 60, 90, 45, 45, 90. Just trying to have that all fresh in your head. All right, let's take a look at this one. Area of a kite. Well, that's our new one. 1/2 d1, d2. Those are just the diagonals. So 1/2 d1, d2. All of it's multiplied. So what's the diagonal of 1 right here? 2 plus 5, 7. d2, 3 plus 3, 6. So you can do it any order you want. You can do half of 6, which is 3, times 7, 21. Or you can do 7 times 6 is 42. Half of 42 is 21. But half of 7, 3.5 times 6, that's just picking the hard way to do that. All right, one more left, and it's on Got It, page 625. 625. Everybody flip there. Got it. Okay, and I copied the picture down. It says, put this here for now. HOV, high occupancy vehicle lane, is marked by a series of diamonds or rhombuses painted on the pavement. What is the area of the HOV lane diamond shown at the right? So they gave us this little part right here, the 2.5, and they gave us this side right here is 6.5. So let's see if we can figure it out. Are we doing this one or the other one? Okay, I think we're just doing the there is just from the Got It, the one that they're doing there. So the diagonals do bisect, so if it's 2.5, then that means this is 2.5. So when I'm figuring out the area, get that pen, it's running out. I know one of them, so I know that's 5. And then I have to get this. But in order to get that, I have to get this first. So we have a situation here where we have a right triangle. So again, remember the relationship. If I have 2 of the 3 sides, I can use Pythagorean theorem. So I'm going to go off to the side and figure that out. 2.5 is a leg. So that's what the A. This is the other leg. So that I'm going to leave as B. And the hypotenuse is always alone. That's across from the right angle. That's 6.5. So we need to solve that. I don't have my calculator. 2.5 squared would be, I don't know what it is. Okay, fine, I've got my calculator. I think it's, okay. Okay, so 2.5 times 2.5, 6.25 plus b squared, 6.5 times 42.525, subtract 6.25. Oh, cool. Square root both sides. And b is 6. Well, that is so slick. So this is 6 right there. So the whole diagonal then is 12. So we're going to go back to our formula and pop in the 12 here. Half of 12 is 6 times 5 is 30 feet squared. And that is what she wrote. So in this one thing today, we've talked about 30, 60, 90 and the Pythagorean theorem. So have those things kind of fresh in your head or and ready to use here as you're trying to figure it out. Because there's lots of right triangles when you're dealing with it. You can do this, make a right triangle. We got these right triangles, these. So you can use those, all those things we learned about right triangles a lot in these. So, all right, that's all I got. Take care.